Okay, in this video, we are going to look at how can we convert a given NFA to its equivalent DFA. Remember, every NFA can be converted to its equivalent DFA. Okay, so we'll look at the conversion. How can we convert a given DFA to, how can we convert a given NFA to a DFA? And don't forget that every DFA is an NFA. So you will not be asked to convert a DFA to an NFA because every DFA is an NFA. So in this video, we are going to look at the conversion from NFA to DFA. Okay, let's get started. The conversion of an NFA to DFA is a straightforward process. You can either use transition tables or with some practice. With some practice, you can actually do it by looking into the diagram, transition diagram itself. But it is always advisable to do this conversion using the transition tables. Okay, so let's go through this question. So we have already encountered this NFA. This is the NFA for binary strings ending in 01. Okay, so I think we have discussed it as a first example in the video introduction to NFA. Okay, so we have already seen its equivalent NFA, equivalent DFA as well. So what is given is the NFA for binary strings ending in 01, right? Now let's understand how we can convert it into its equivalent DFA, right? So what we want to do here is that we have to, if the transition table is not given, you can actually draw the, you can actually fill in the transition table from the given diagram. Now let me fill in this transition table from the given diagram. So the starting state here is Q0. So let me write Q0. And since this is the starting state, you have to indicate this with an arrow here. Similarly, a final state. Okay, remember that a final state in a transition table also has to be indicated by circling it. Okay, so from Q0, if you look from Q0, upon seeing the symbol 0, you have two choices. You have two options. You can stay at Q0 and Q1. So your transition will be to Q0 and Q1. Okay, so you are going to write the set Q0, comma Q1. Okay, because two paths are there. Now from Q0 to 1, there is only one way. That is again going back to Q0. Okay, and now our next state is Q1. And from Q1, if you are getting a 0, so if you look at 0 transition from Q1, it's actually not defined. So it is defined to a null set. Now from Q1 upon 1, you are going to Q2. And Q2 is going to be your final state. And remember, in a transition table, you have to indicate, you have two ways of indicating. Normally, there are two ways of indicating that it is a final state. You can just give one circle. Okay, this is one method. Alternatively, you can also give a star. Okay, if you are giving a star just before Q2, then that also specifies that Q2 is going to be your final state. So anyway, you have to do only one of these. Okay, so I'm just using circle here. Okay, from Q2, upon getting a 0, the transition is not defined. So here again we have a null transition. Okay, let me use the same color. Okay, so I have transition to null set. Again, Q2 upon 1 is also a null set because the transition is not defined. So this is going to be the transition table for this NFA. Okay, so what we want is actually to convert this into its equivalent DFA. So what we are actually going to do is that we are looking at this table. We are going to create the DFA table. Okay, so it's going to be very easy. I will tell you the step-by-step method of how we can convert a given NFA table to a DFA table. So this is going to be your NFA table indicated in red, and this table, which is indicated in green color, is your DFA table. Right? It's going to be your DFA table. Okay. So what essentially we have to do is we have to look at Q0, the starting state, and then we can just copy that information to the DFA table. Okay, so that's the first step. So I can write Q0, and remember, upon 0, you are actually in your NFA. You are going to, it is mapped to your set Q0, Q1. Now I'm going to group that into a single state called Q0, Q1, right? So I'm just calling it Q0, Q1. Okay, and I am going to consider this as a single state. Okay. Now what about Q0 to 1? It is defined to Q0 itself. So I can just write that. Now looking at this row, you can understand that Q0 Q1 is something new here. Okay. So what I want is to write the transition for Q0 Q1 now. Okay. So Q0 Q1 is something new as far as the DFA is concerned. So what we are going to do is, whenever we encounter such a new state, we are going to write its transitions. So let me write the transitions for Q0 Q1 here. Okay, so Q0 Q1. Okay, so when I want to look at the transition of Q0 Q1, okay, let me make it very clear. This is going to be Q0 Q1. Okay, so when I look into Q0 Q1, the transition for 0 on Q0 Q1, I have to see both the transitions, that is Q0 on 0 and Q1 on 0. So then I have to combine the information. So we know that Q0 on 0 actually has got two, Q0 on 0 is mapped to Q0 Q1. Okay, so what about Q1 on 0? Q1 on 0 is a null set. Okay, so you have to combine these two. Okay, we know that Q0 on 0 is Q0 Q1, and Q1 on 0 is a null set. So you have to combine these two. So if you combine a null set, that doesn't make any difference. So we can just write Q0 Q1 here. Okay, so let me write Q0 Q1. Okay, and for transition on 1 from Q0 Q1. So we know that transition for Q0, the transition on 1 is Q0 itself. So you can see that Q0 transition on 1 is Q0 itself. And for Q1, transition on 1 goes to Q2. Okay, so we have to combine these two. So it will be Q0 Q2, right? Now again we have another new state here, which is Q0 Q2. Okay, so Q0 Q2 is something which we have not seen till now. Now what we want to do is we want to write the transitions of Q0 Q2. Okay, so I have to write Q0 Q2 here. Okay, so from Q0 Q2, if you look for this transition on 0, so I know that Q0's transition on 0 goes to Q0 Q1, right? Q2's transition on 0 is not defined. So again, here I will be having Q0 Q1. Now what about Q0's Q2's transition on 1? Okay, so we can see that Q0 on 1 goes to Q0 itself. Okay, and what about Q2 on 1? Q2 on 1 is not defined. Okay, so Q0 Q2's transition on 1 goes to Q0 itself, right? Okay, so here if you look at this row, we don't have any new information. We don't have a new state. So we can possibly stop here and then draw the DFA. Okay, so drawing a DFA is going to be very easy. And before that, we have to actually mark the final state, right? So for marking the final state, we should look at the final state of the NFA. So we know that the final state of the NFA table is Q2. So we know that it's Q2. Okay, or if you are given with a diagram, you can understand by looking at the diagram, you can understand that Q2 is the final state. So what you actually want to do is that look for all the states containing Q2 here, and all the states which contains Q2 as a state will be final states. Now in this 3 states, Q0, Q2 is the only state which contains Q2. So this is going to be your final state. So mark it with a circle. Okay. So you have identified Q0 as your starting state. Q0 is your starting state, and Q0, Q2 is going to be your final state, right? Okay. So now what we can do is we can draw the DFA diagram very easily. Okay. So let me draw the diagram for the DFA diagram, right? Okay. So so Q0 is going to be my starting state. Q0. Let me use the green color itself. So Q0 is going to be my starting state, right? And Q0 on 0 goes to Q0 Q1. Okay, so I am writing Q0 Q1. Let me write the states, all the states first. So Q0, then Q0 Q1. I also have Q0 Q2. So these are the states in my DFA. So Q0 on 0 goes to Q0 Q1. So the only thing that you need to do here is refer to the DFA table and draw the diagram accordingly. And now Q0 on 1 goes to Q0 itself. Okay, so this is Q0 itself. And now you have to draw the transitions on Q0 Q1. Q0 Q1 on 0 goes to Q0 Q1 itself. Okay, so Q0 Q1 on 0 goes to Q0 Q1 itself. Q0 Q1 on 1 goes to Q0 Q2. No, Q0 Q1 on Q0 Q2 on 0. Q0 Q2 on 0 goes to Q0 Q1. So this is going to be its transition. Okay. And Q0 Q2 on 1, Q0 Q2 on 1 goes to Q0. Okay. So Q0 Q2 on 1 goes to Q0. Okay. Now again, don't forget to mark your final state. So we have already identified Q0, Q2 as our final state. So we have to double circle it. This is a very important step that you should never forget. So once we have designed this DFA, we can call each of these states with a different naming. For example, Q0, instead of Q0, I can say it as an A. This state, instead of this, I can call it as B. This state, instead of Q0, Q2, I can call it as C. This can be done to avoid confusion, right? So we are only having 3 states. Okay, so we can call them with single letters. So A, B, C. Okay, I mean, this is not a mandatory step, but this is advisable. Okay, so to recap, what we did is that we were given with an NFA diagram. So we converted that to a transition table, NFA transition table, and then the NFA transition table, we could convert that to a DFA transition table based on the data in the NFA transition table. We converted it to a DFA transition table, and then we could convert it to a DFA diagram. Again, if you are given with an NFA diagram, you can actually directly convert it into a DFA diagram. Okay, so this requires some practice and intuition. I mean, it's not very complicated. It's very easy only. So instead of doing all these steps, by looking at the NFA diagram, we can just directly convert it into its equivalent DFA. So if you're adopting this method, you need to be very careful so that you don't make any mistakes. Okay, so we'll see an example in our next slide. So what I'm going to do here is I'm going to take the very same example that we have discussed in the previous slide and then convert it directly to the DFA. Okay, so we are not going to use the tabular method here. Instead, we are trying to convert it directly to the DFA that we want. Okay, so what we can actually do here is that we will start with the starting state. Okay, so don't forget to mark the starting states here. So I will also start at Q0. Okay, and from Q0, if you look at the transitions, okay, so what I'm interested in is to find the transition of Q0 on 0. Okay, so similarly Q0 on 1. So when I find those two transitions, Q0 on 0, there are 2 possibilities, Q0 as well as Q1. So I'm going to combine them as a state, as a single state, right? And what about Q0 on 1? So Q0 on 1, there's only one option. It goes to Q0 itself. Okay. So now I'm going to draw these transitions. So now I know what is Q0 on 0. So Q0 on 0 is Q0 Q1. So I'm going to call this as Q0 Q1, and this is going to be a new state which I have not seen anywhere. So Q0 Q1 is a new state on 0. Okay, so if you're getting a symbol 0, it goes to Q0 Q1, and on 1 Q0 goes to Q0 itself. On 1 Q0 goes to Q0 itself, right? Now see understand that Q0 Q1 is a very new state for us. Now I'm going to write its transitions. Okay, so remember, whenever I want to write Q0 Q1's transition on 0, I have to look for from both the states. That's, I have to consider Q0 as well as Q1, right? Now let me do it here. So let me take my pointer to make it more clear. So Q0, look at Q0 on 0, or I will split it and write that will be better. So to find this, I have to actually do both Q0 on 0 and Q1 on 0. Okay, then I have to combine the results to obtain the result. Okay, so Q0 on 0, I know there are two possibilities. That is, one of them is Q0 Q1. I mean, and there are two possibilities, Q0 and Q1. So Q0 Q1. And what about Q1 on 0? Okay, Q1 on 0 is not defined. It is a null set. Okay, so now you have to combine both of this. So if you combine with a null set, you are going to get the same result. So it will be giving you Q0 Q1, right? So what it essentially means is that the transition on Q0 Q1 on 0 goes back to itself. So Q0 Q1 on 0, to find that, we have actually found Q0 on 0, we got Q0 Q1. Then we did Q1 on 0, we got null set, and then we combined them, we got Q0 Q1 again. And that's why we are drawing the transition, the same transition. Okay, it goes back to Q0 Q1. Now I want to find the transition of Q0 Q1 upon 1 now. So the same procedure has to be applied. So Q0 Q1 on 1. Okay, so to find this, we have to find both of them. That is Q0 on 1, as well as Q1 on 1. Okay, so now Q0 on 1, look at the NFA diagram. Q0 on 1 gives you Q0 itself, right? Similarly, Q1 on 1 gives you Q2. Q1 on 1 gives you Q2. So you have to combine this. So now you are going to get Q0 Q2. Okay, so that means if you're getting a 1 from here, that is from Q0 Q1, if you see a 1, then you're going to go to a new state, it's Q0 Q2. So why is this a new state? So we have not seen, this state is not present in anywhere. That's why it's called a new state. Now since this is a new state, I have to also find the transitions from Q0 Q2, right? So I'll write it here, Q0 Q2. I'll write it in this side. Q0 Q2, I have to find the transitions on 0. Okay, for 0 first. So I have to do for Q0 on 0. Similarly for Q2 on 0. Q0 on 0, I know that Q0 on 0 is Q0 Q1. Q0 and Q1, so Q0 Q1. Q2 on 0 is null set. Okay, so combine them, you'll get Q0 Q1. Right. So that means upon seeing a 0, the transition gets you to Q0 Q1. Okay. Now you also have to do for Q0 Q2 on 1. So Q0 Q2 on 1. So to do that, we have to find both Q0 on 1, similarly Q2 on 1. Q2 on 1. So we know that Q0 on 1 is Q0 itself. Q2 on 1 is null set. So combine both of them. So you'll get Q0. Now that means the transition of Q0, Q2 upon 1 is going to get you back to Q0. So this is going to be the transition. Okay. So okay. So again, don't forget to mark the final states. Okay. So here we know that our NFA final state in our NFA is Q2. Final state in our NFA is Q2. So we have to mark our, when you look at the DFA, you have to mark every state which contains Q2 as a final state. Now in this DFA, we have Q2 in only one state, that is Q0, Q2. Okay, so that state, so this is that state. So you have to mark that as a final state. So you don't have Q2 present in any other state. If you have Q2 present in any other states, then you have to mark that as that also as a final state. Remember, there can be multiple final states in a DFA. So whenever you are applying this method, you have to be super careful. Okay, so it is very easy to make mistakes. Even I am doing this, I am retaking this this part of the video second time, since I did a mistake in my first take. So so you have to be very careful when you're doing this. So let me also give you a very quick recap of what we did. So we are actually given with this NFA diagram. Okay, so even NFA transition table is also possible. So from the transition table, you can actually draw the transition diagram. Okay, now from this transition diagram, what I'm going to, how we did is that we looked at the starting state. We have exactly copied that starting state, and then we have to define transitions on 0 and 1, right? So I have defined transitions on 0 and 1 for Q0. That's the first step I did. So when I did that, I got a new state, which is Q0, Q1. Now what I'm going to do is I'm going to define transitions on 0 and 1 for Q0, Q1, which is my new state. So this is how we defined transitions, Q0, Q1's transition on 0. Also, we have to also find the transition of Q0, Q1 on 1. So again, when it was done, we again got a new state, which is Q0, Q2. So we have to do we have to find the transitions of Q0, Q2 on 0 and 1. That's what we did here. So you can see this rectangle where we did Q0, Q2's transition on 0. Now here, even though it is a little bit congested, here we did the transition of Q0, Q2 on 1. So once we have done all such transitions, and you have worked out all the new states, then your DFA will be complete, right? Now again, don't forget to mark your final state. Okay, the final state here is going to be Q0, Q2. Okay, let us solve this question now. So the question is to convert the NFA represented using the transition table. Okay, so here you can see the transition table of an NFA, and we are asked to convert it into its equivalent DFA. So what we can actually do is that we can actually look at the NFA table and create the transition table for the DFA. And once we are having the transition table for the DFA, then we can actually very easily convert it into its transition diagram. So let's look at how we can convert this particular NFA table, the transition table of your NFA, to the transition table of your DFA. Okay, let's start filling up the transition table for the DFA. So the first step is to write the starting state as such. So we have Q0 as the starting state, right? And now you can copy the transitions from the NFA table itself. So it is going to be Q0, Q1. So I'll write Q0, Q1 here. And look at here, we have a new information here, which is Q1. Okay, so whenever you are filling up the DFA table and you are encountering a new symbol, right, you have to write its transitions. So here, important thing here to remember is that you started with Q0, then you got Q0 and Q1. Okay, so Q0 and Q1. So Q1 is a new state for you.
Q1 is a new state for you. So you have to write the transitions for Q1 now. So let me write the transitions for Q1, right? So when I write the transitions for Q1, again, I have to refer back to the NFA table. So in the NFA table, it is indicated that, upon transition for 0, there are two possible transitions, Q0 and Q1. So I will combine both of them and write it together as a new state here. So I'll be writing it combined Q0, Q1. And Q1 on 1 from the NFA table, it's clear that it is going to be Q2. Okay, so while looking at these, the states in this particular row, you can identify that both of this, that is Q0, Q1, as well as Q2 is new as far as this table is concerned. Okay, so what you need to do is you have to write the transitions. You have to start writing the transitions for those. So the next thing that I'm going to do is I'm going to write the transitions of Q0, Q1. Okay, so let me write the transitions for Q0, Q1 now. Okay, so I'll be taking Q0, Q1. Okay. Okay, so when you look at Q0, Q1, you have to look for both Q0 and Q1 while writing the transitions. The same procedure that we have followed in the previous slide. So now you have to look at the transitions. You have to look at the transitions for 0 from both Q0 and Q1. Okay, so when you look at the transition of Q0 on 0, it is going to be Q0. Again, you have to look at you have to also look at the Q1's transition on 0. So when you look at Q1's transition on 0, it is going to be Q0, Q1. So when you combine these together, again you will get Q0, Q1, because Q0 is a duplicate here. So again you will get Q0, Q1. Okay, so let me write the transition on 0 as Q0, Q1 itself. So when you're combining that, you'll get only Q0, Q1. And what about Q0, Q1's transition on 1? Q0, Q1's transition on 1. So Q0's transition on 1 here, again, from the NFA table, look at the NFA table. Q0's transition on 1 gives you Q1, and Q1's transition on 1 gives you Q2. So you have to combine both of them to get Q1, Q2. Okay, so your transition here is going to be, so the transition here is going to be Q1, Q2, Q1, Q2. Okay. Okay, so we have written the transitions for the state Q0, Q1. Again, don't forget that Q2 was also a new state in this table. Okay, so you have to write the transitions for Q2 now. Okay, so you have to follow the ordering. Okay, so whenever you find a new state, you have to write its transitions and then follow it up. So here, when we did the first row, we got Q1 as a new state. Then we have written its transitions. So then we got Q0, Q1, Q0, Q1, and Q2. Q0, Q1, and Q2. So both of them were new states as far as this particular table is concerned. So what you need to do is to write the transitions for Q0, Q1, followed by the transitions for Q2. So once I've written Q0, Q1's transitions, again here again you have another new state, which is Q1, Q2. Okay, so before actually going to write the transitions for Q1, Q2, we have to finish off writing all the transitions for the newer states obtained in earlier. Okay, so Q2 is remaining here. So we need to write Q2's transitions before going to write the transitions on Q1, Q2, right? So let's write the transitions of Q2 here now. Okay, so now from Q2, you upon 0 you are getting Q1 by referring to the NFA table. You can easily identify that. And Q2 on 1 gives you Q0, Q1. So I'm going to write Q0, Q1 here. Right. Okay, so what I have done till now is that I have written my first row. I have identified Q1 as a new state. Q1 as a new state was identified. Now Q1's transitions were written. Okay, and upon writing the transitions of Q1, I got two new states, that is Q0 Q1 and Q2. Q0 Q1 and Q2. Okay, and upon writing Q0 Q1's transitions here, I've also added Q0 Q1's transitions here. Again I'm writing Q0 Q1's transitions, right? So upon doing that, again I'm getting a new state, but I have to first finish this off. Q2 was a new state, right? So even though I'm getting Q1 Q2 again as a new state, okay, it is better to finish off with Q2 because we got Q2 as a new state in the earlier step. Okay, so Q2, I'm going to write the transitions of Q2. So while writing the transitions of Q2, again I got a new state. That's okay. It's not a new state. It's something which we have already seen. Q0 Q1 is something which we have already seen. Okay, so now we are pending with writing the transitions of Q1 Q2. So let's write the transitions of Q1 Q2. Okay, so Q1 Q2. So upon looking at Q1 Q2's transitions, okay, the transitions of Q1 Q2, you have to look for both Q1 as well as Q2. So when you look at Q1's transition on 0, Q1's transition on 0 from the NFA table, it's Q0 Q1 for Q1, and for Q2 it's going to be Q1, right? So when you combine, again you will get Q0 Q1. Okay, so when you combine those, you'll get Q0 Q1. Okay, let me use the same color. You're going to get Q0 Q1 itself. Now, what about Q1 Q2's transition on 1? Q1's transition on 1. Q1's transition on 1 gives you Q2, and Q2's transition on 1 gives you Q0 Q1. Look at this. You have all three entries here. So Q1's transition on 1 gives you Q2, and Q2's transition on 1 gives you Q0 Q1. So when you combine this, you'll get Q0 Q1 Q2. Okay, that I can write here. That I am going to write here. So Q0 Q1, Q0 Q1, and Q1 Q2. So this is so this contains all the states Q0 Q1 as well as Q2, right? So when you look at this row, again you have a new state which we have not written the transitions, that is Q0 Q1 Q2. So Q0 Q1 Q2 is going to be a new state for you. So what essentially we need to do is that we are not pending with any other new states, so we can write the transitions on Q0 Q1 Q2. Okay, so let's try to write the transitions of Q0 Q1 Q2 on 0 and 1. So let me write Q0 Q1 Q2 here. Now when I want to write the transition of the state Q0 Q1 Q2 on 0, I have to combine all the entries that is reflected in the transition 0 here. That is the and look at the NFA table. I'm going to, so we have to combine all these states. Okay, so what essentially we are going to get here is that again we are going to get Q0. Okay, when we combine this, we can see that there are some duplicate values. So the unique values are Q0 and Q1. Okay, so you can combine Q0 Q1. Okay, so you'll be getting Q0 Q1 as the entry here. Okay, so let me write Q0 Q1 here. Again for transition 1, I have to combine all the entries in the one transition. Okay, so I have to combine all this. So when you look at those entries, when you look at all these entries, upon combining, you'll again get Q0 Q1 Q2. Okay, so let me write Q0. So you'll be getting Q0, Q1, Q0, Q1, Q2. Now, if you look at this row, when we look at this row, we have Q0, Q1, and Q0, Q1, Q2. So these are the states which we have already seen, and we have written its transitions also. So you can see Q0, Q1 we have handled here, and Q0, Q1, Q2 is handled here. So there is nothing new in our in this row. So we can stop the process and then draw the DFA. So understand that during this process, whenever we encountered a new state, we used to write its transitions. So the first new state we encountered was Q1, and then we wrote Q1's transitions. So upon writing Q1's transitions, we encountered with two new states, Q0 Q1 and Q2. So then we have written Q0 Q1's transitions and Q2's transitions. And remember, when we wrote Q0 Q1's transition, we got another new state, that is Q1 Q2. So we also have written the transition of Q1 Q2 here. So this was also a new state when we did it. Okay. So when we did Q1 Q2's transition, we got Q0 Q1, but that's already encountered. And we also got Q0 Q1 Q2. So since Q0 Q1 Q2 here again is a new state, so we have written its transitions. So we have also written the Q0 Q1 Q2's transitions on 0 and 1. And when we look at the transitions, we got Q0 Q1 and we got Q0 Q1 and Q0 Q1 Q2. So there is nothing new in this. So we have already encountered Q0 Q1 and Q0 Q1 Q2. So when you are getting such an entry where there is nothing new, then you can actually stop this process and draw its equivalent DFA. So drawing a DFA diagram from this table is going to be very easy. You just have to draw the states and then connect the 0 transition and 1 transition from every state. Okay, so when you look at this DFA diagram, when you look at this DFA table, you can understand that how many states are there? There's going to be 1, 2, 3, 4, 5, 6. There are 6 states. Okay, but in the NFA diagram we had only 3 states: Q0, Q1, and Q2. So again, remember this DFA that we have we are getting is not necessarily the minimum DFA. So it may not be the minimum, may not be a minimum DFA. Okay, may not be a minimum DFA. So it may be quite possible for you to minimize this DFA further, right? Again, another very important thing that you have to remember here is that if a DFA has n states, if an NFA, if the given NFA has n states, the maximum possible number of states in your DFA can be 2 raised to n. Okay, you can have 2 raised to n states in your DFA. Okay, so this is very important. This is going to be very important. Why? Because in this case, look at this case. We had 3 states in our DFA, which were Q0, Q1, and Q2. Okay, so the maximum possible number of states in your DFA is going to be the superset of this the states in your NFA. And we have already seen that the superset of a set contains 2 raised to n elements, and we have actually listed it out in one of our earlier videos. So if the superset of this NFA will contain all combinations starting from null set. Okay, so I will just quickly tell you which are the states. It's going to be the null set, then the set Q0, Q1, Q2, then the combinations like Q0, Q1, Q1, Q2, Q0, Q2, and we also will have Q0, Q1, Q2 as a single set. So if you count all those, in this particular case, you are going to get 2 raised to 3. That's going to be 8. Anyway, when we designed this DFA, we got only 6 states. We got only 6 states because we are writing the transitions only upon getting a new state. Okay, so that's why we got away with 6 states. But if you are writing all possible states, then you can get 2 raised to n states, right? So the maximum number of states, okay, in a DFA upon converting an NFA which contains n states is going to be 2 raised to n. So you cannot write more than 2 raised to n states for a DFA when you convert an NFA with n states. So that's a very important information. Again, don't forget about your starting state and final states to mark the starting states and final states in your table. So we know that Q0 is our starting state. And all the states, and we know that Q2 is our ending state, is our final state from the given NFA. Okay, so Q2 is represented as the final state in our NFA. So what we can do here is that all the states in your DFA table which contains a Q2 will now be the final states. So when you look at this table, see here Q1, Q2 is present here. So this is going to be a final state. Again, Q1, Q2 again is going to be a final state because it contains Q2. And again, this Q0, Q1, Q2 also contains Q2. So this is also going to be a final state, right? Okay.
Now what we have done here is we have applied the tabular approach. That is, we are given with the NFA transition table, and then we have converted it into the equivalent DFA transition table. So this is called the tabular method. And we can also try for the diagrammatic approach, where once we know about the NFA diagram, we can actually convert directly to the DFA diagram. So for this particular question, you can actually draw the NFA diagram from this NFA transition table, and then try to convert it directly to the DFA diagram. And once you got the DFA diagram, you can actually verify your solution with the table available here. So if the transition table of the DFA that you obtained has the same values shown in this table, then you can verify that your answer is correct. So we will see more examples of converting an NFA to its equivalent DFA in our next video.